All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, you're going to have x plus 12 times x plus 12, or you can write x plus 12 squared. Either one is fine with me. Okay, for the math knowledge question, it asks how much more must the average value per stamp rise for the total to be exactly $300. So he currently values the stamps at $51.85, and he has 20 of them. And so we want to know when he gets more than exactly $300 more than what he paid for them originally. So $300 for 3 stamps is going to be a price of $15 per stamp. So they're wanting to know, when is it going to be a $15 increase? So he started at $43.75. So that would put the price, whenever it increases by 15, at $58.75. And he's already at $51.85. So if you subtract that, you're going to get $6.90. And so that's how much more they're going to have to rise in value for it to be $300 more than what he paid for the stamps. All right. So we're looking at lesson 25 today. We're going to look at the constant multiple rule for derivatives and then derivatives of sums and differences. So both of these are going to be using this little formula that we worked on with our last lesson. So hopefully you remember that. You definitely want to learn that formula. The derivative of x to the n is n times x to the n minus 1. So both of the concepts today use that formula. So what are the derivatives of these lines? Well, what do we remember about derivative? Derivative equals slope. So what is the slope of the green line? The slope is 2, so the derivative is 2. What is the slope of the red line? Well, the slope is 1, so the derivative is 1. And then what is the slope of the blue line? The slope is 1/3, so the derivative is 1/3. Okay, so that's how you can find derivatives of straight lines. Now, the derivative of a product and a constant, the derivative of a product of a constant and a function, it's just going to be the product of the constant and the derivative of the function. So if you have n times f of x and you take the derivative, that's just going to be n times the derivative of your function, where n is some random number. So c f of x, you're just going to take the derivative of your f of x, and whatever you get for that, multiply it by c. So we have 20x cubed, and we want to find the derivative. So we're going to take the derivative of just x cubed, because that's just some number. So the derivative of x cubed would be 3 and then x to the 2. And then you just multiply, and so you get 60x squared. And so that's how you would take the derivative of a constant in front of your function. Okay, so we want to find the derivative of these two. So derivative, we're going to do 3 times the derivative of x to the square root of 2. So we bring our exponent down, so that's square root of 2, and then x, and we're going to do our exponent minus 1. Square root of 2 minus 1 is just some random number, some decimal, and we're just going to leave it as square root of 2 minus 1. We're not going to try and simplify it further. So if you multiply, you get 3 square roots of 2 times x to the square root of 2 minus 1. You can leave it just like that. For g, the derivative of it, we're going to do negative 14 times the derivative of x to the negative 5th. So we bring the negative 5 down, and then we do we do negative 5 minus 1. So some of y'all may want to put a negative 4 there, but that's not correct because it's always one number lower than your exponent. So negative 14 times negative 5 is a positive 70, and then x to the negative 6. And so that would be your derivative. You got to be careful when you have negatives for your exponents, because you'll often put the wrong one. Okay, so now we're going to look at the derivative of sums and differences of two functions. All you have to do, it just equals the sum or the difference of the derivatives of the individual ones. So this looks a little bit confusing. If you have the derivative of f plus g of x, you're going to do the derivative of f plus your derivative of g. So derivative of f plus the derivative of g. You have derivative of f minus g of x, split them into 2, and you have the derivative of f minus the derivative of g. You just take the derivative of each individual function. So looking here, in case you can't tell, that's a negative 3 in your exponent. We want to find the derivative. So our derivative, we're just going to take the derivative of each individual term. So 4 times the derivative of x to the negative 3, we would have negative 3, and then x, we would do negative 3 minus 1. Then we would do minus 2, derivative of x to the square root of 2. So bring your exponent down, and then x to the square root of 2 minus 1. Now the derivative of 4. What is the derivative of a constant? Is there an x here? No. Let's think about y equals 4. What is the slope of y equals 4? That's a horizontal line, and so the derivative equals 0. So you can put plus 0, but it's going to go away. The derivative of a number is always 0. Okay, so now we're just going to distribute. We have negative 12 x to the negative 4 minus 2 square root of 2 x to the square root of 2 minus 1. And so that would be your derivative. Let's look at another example. See if y'all can try this one by yourself, maybe. If not, y'all can keep watching and I'll go over it. So for this one, we always want them to be in the numerator. So for the first term, we're going to need to write it as 3x to the negative 4. And the second one, we don't need to change anything. For the next one, we need to make it 2x squared and then plus 4. So maybe now you can try it by yourself. So we're going to take the derivative of the first term. So we're going to do negative 4 and then x to the negative 4 minus 1 minus 2 pi comes in front, and then x to the pi minus 1. That's going to stay just as pi minus 1. And then plus 2x to the 2 minus 1. And then the derivative of 4 is 0, so we don't have to write that. So then you're just going to simplify. You're going to have negative 12x to the negative 5 minus 2 pi x to the pi minus 1, and then plus 4x to the first power. And so that would be your answer for that one. Okay? So now let's see if you can find the derivative of this one. So now instead of our variable being an x, it's a t, but you do the same concept. So y'all pause the video real quick and see if you can figure it out. Alright, so the derivative of s, you're going to do negative 16, 2t to the 1, so that's going to be 2 minus 1, which is just 1, plus 42. There's an understood 1 here, so that would come to the front, and then you would do 1 minus 1 if you need to work that out. So that'd be negative 32, and then just t, plus 42, and 1 minus 1 is 0. T to the 0 is just a 1, so you just have 42 for that last term. So that's your answer for that one. So that's how you take derivatives of sums and differences. On your homework, you're going to have several that are going to practice going over those, so make sure that you really work to make sure you understand how to do them. Now number 3 says use the definition of the derivative. So for that one, you're going to need to work it out completely. You can check your answer with the formula that we've been using today, but for that one you need to make sure to work it out. 4, 5, 6, 7, 8, 9, and 10 all just ask you for the derivative. So you get to do exactly what we did in this lesson. Just take the derivative. You don't have to do the definition of the derivative and show all of your work. So hopefully those will go a little bit quicker for you than number 3 will. So make sure that you do your homework tonight so that we can go over any questions that you have tomorrow.